In working with percents, sometimes you have the percent, but not the whole, but rather a part. But it's not the part you're looking for. In such cases, you need to find the percent of a difference. In this video, we'll look at examples where you have to find a percent difference in order to solve a problem. Let's look at an example. At a school, 17% of the students take the bus. If 249 represents the number that don't take the bus, how many students take the bus to school? In this example, we are given 17%, and this represents the fraction of students that took the bus. So if we draw a circle and section off 17%, that's the fraction that took the bus. But we're given 249, which represents the other part of the circle. Those who didn't take the bus. So the percent that we're given doesn't align with the numerical part. We need to adjust the percent. This part of the circle, the 249, represents 100 minus 17, or 83%. Now we can set up an equation to find the total number of students that take the bus. 100 minus 17% of x equals 249 students. This becomes 83% of x equals 249 students. We can now write the percent as a decimal and solve for x. To solve for x, divide both sides of the equation by 0.83 as shown here. The left side simplifies to x. On the right, we divide 249 by 0.83 to get 300. This is the total number of students in the school. Now we can find how many students take the bus. It's the 300 we just calculated, minus the 249 who don't take the bus. The difference is 51. There are 51 students who take the bus. Let's look at another example. Magic Johnson's lifetime free throw percentage was 84.79%. If in a given season he missed 29 free throws, how many did he make? Round to the nearest whole number. The 84.79% is the percent of free throws he's made, but we're given the number of free throws he didn't make in a given year. If we draw a circle, this large section represents the 84.79%. But we don't know what number this is. We are told the other section of the circle, the free throws he didn't make, is 29. In terms of percents, the 29 represents 100 minus the 84.79%. We can write this as an equation, as shown here. We can now write the percent as a decimal and solve for x. The percent of free throws not made is 15.21%. The equation becomes 0.1521x equals 29. To solve for x, divide both sides by 0.1521 as shown here. The left side of the equation simplifies to x. On the right side, we divide 29 by 0.1521. We need to round this quotient to a whole number, and we get 191. This is the total number of free throw attempts. To find the number of free throws made, subtract 29 from 191 to get 162. This is the number of free throws that Magic Johnson would have made in a year when he missed 29 free throws. Let's look at a final example. For each new generation of salmon, only about 4.44% survive to spawn the next generation. If 2,750 salmon failed to spawn in a certain river, how many salmon succeeded? Round to the nearest whole number. We are given the percentage of salmon that spawn, but the number of salmon that don't spawn. To find the percent of salmon that didn't spawn, find 100 minus 4.44%. This gives rise to this equation. 100 minus 4.44% of x equals 2,750 salmon that didn't spawn. This becomes 95.56% of x equals 2,750. Solve for x. Divide both sides by 0.9556, as shown here. Rounding to the nearest whole number, we get 2,878. This is the total number of salmon. To find the number that spawned, subtract 2,750 from 2,878 to get 128. So only 128 out of 2,878 salmon spawned.